Hi, this is Miss Webb. So we're going to kind of switch to statistics from probability. We're going to talk about z-scores and how to use technology and tables to estimate the area under a normal curve. And we're going to interpret probabilities in context, which is really the most important thing when we're doing probability statistics. Okay, if you go pull out your notes, also I have given you two online screen functions to be able to look up standard deviation, to look up a few other things. So you want to get those out. And then also I have a table for the area under a curve, which we'll use for the very last example. So let's get started. First, I want to talk to you about what's meant by a normal distribution. Is it normal? Is it skewed to the right or to the left, or is it neither? So let's look at these, and if you were looking at these data models, on this very first one right here, I think what do you think that would be? I think that's approximately a normal distribution. Okay, it's symmetrical. I could cut it in half. One side would look like the other. Okay, how about this one? That looks approximately normal. I think that would be a pretty fair guess. How about this one over here? Ooh, it's skewed to the right. The tail on the right is a lot longer. Okay, how about this one? I think that one's it's a pretty good approximation of a normal distribution. How about this one here? Now this one here throws a lot of people because if you cut it down the middle and you fold it in half, there would be about the same on this side as on this side, but it's not in that mound shape like these are up here. So we want to make sure you understand that a normal distribution is a distribution, and let's fix that. I can't spell evidently. Okay, a normal distribution that has a particular symmetric mound shape. So it needs to be symmetrical, and it also has to be mound shape for you to think of it as a normal data distribution. It has to have both. Okay, so I'm going to look at some of these examples they give you. Suppose that you took a math test and a Spanish test. Now the mean score for both tests is an 80. So the average is an 80. You got an 86 in math and a 90 in Spanish. Did you necessarily do better in Spanish relative to your fellow students? Well, let's go look. Okay, if you assume a normal distribution, if the mean is 80 and the standard deviation of the math scores was 4, okay, so if you knew the standard deviation was 4, the score of 86 in math is about 1.5 standard deviations above the mean. Right? 84 plus 2 more, I'd get an 86. Now, if the mean is 8 and the standard deviation of the Spanish scores was an 8, the score of 90 in Spanish is only it's a 1.25 standard deviations above the mean. So relative to other students, I did better in math. Do you see how it's important that you consider all the data, the average and the standard deviation? And that's some of the things that we're going to look at today. Okay, z-scores. Now, I'm going to have a little bit of a tough time in this lesson because I'm not sure how many of you have seen this before. So I'm going to go over it in detail. Z-scores measures the distance in units, okay, of the standard deviation. Okay, so you're looking at the mean, okay, between the mean and the standard your units and your standard deviation. For example, a z-score of 1 represents an observation that is a distance of 1 standard deviation above the mean. So if the mean was 50 and you had a standard deviation of 4, at 54 that would be a z-score of 1. In the above example, the z-score for math is 1.5. So remember the mean was 80. The z-score for math is 1.5, and the z-score for Spanish is 1.25. And that has to do with, you had to know what the standard deviation was. Okay, a negative z-score indicates the values that are below the mean. So if you're below the mean, your z-score would be over here. And I think it'll make a little more sense when we do some examples. Okay, when you're calculating probabilities associated, and this is why it's important we reviewed it first, it has to be a normal distribution. Z-scores are often used. A z-score for a particular value measures the number of standard deviations. The number of standard deviations from, or here it is, away from the mean. From the mean. A positive z-score corresponds to a value that is above the mean, and a negative corresponds to a value that's below the mean. But you have to know that standard deviation. The letter z is used to represent a variable that has a standard normal distribution where the mean is 0. So in this one, we're going to assume the mean is 0, not 80, but it's 0. The standard deviation is 1. So here would be the z-score over here at 1, and if it was below the mean, it would be over here at -1. This distribution was used to define a z-score. A z-score is calculated by take whatever your value is and subtract the mean. So let's just do one like this. So if you're looking at the mean at 0 and you're looking at 1, then it would be 1 minus 0. And if your standard deviation is 1 as well, then that's where you get your z-score is 1. Okay, let's just do some examples with these. The price of printers in a store, there's that mean of 240 and a standard deviation of 50. The printer that you eventually chose cost 340. What is the z-score for the price of your printer? So think of it, here is your mean is at 240. 240. And the standard deviation is 50. Now you paid 340. So 240 plus 50 would be 290. There's one standard deviation. Another standard deviation of 50 would bring it up to 340. Okay, so your z-score would be 2. So remember, let's see if we can figure out. Your value is 340. Subtract the mean of 240. Your standard deviation was 50, and you got 100 divided by 50. It's equal to 2. Okay, how many standard deviations above the mean was the price of your printer? 1, 2. 2. Okay, let's see how it's going to go. Here, let's go over this example as well. Okay, Aisha's, I don't know how you say that, is 63 inches. The mean height for boys at his school is 68.1 inches. Standard deviation is 2.8. So the z-score would be the value, which is 63, minus the mean. Where's the mean? 68.1 divided by 2.8. Let me get my calculator out and we'll do that. And let's see what we got. Hold on a second. Okay, I got a negative 1.82. Negative 1.82. Do you see why it's a negative? Because his is below the mean. So what's the meaning of this value? Well, when you talk about that, it says his height is 1.82 standard deviations below the mean height for boys at his school. Does that make sense? Okay, how about explain how a z-score is useful in describing data? So when you have a z-score is useful when how far is a particular point is from the average. Gives you a good idea of how far away it is from the average. Okay, let's look at some others. Okay, they would like you to be able to use z-scores and a graphing calculator to find normal probabilities. Okay, the problem is Most of you are at home and do not have your calculator, and I don't know if you have a TI-84. So what I want to tell you is the general form of this, okay? It looks like this, normal CDF. That is a function on most calculators, and you'll get parentheses, and they want you to put the left Z-bound and the right Z-bound. Okay, so before your SAT, you need to know how to get these functions on your calculator. This would be really important, okay? So don't go into that SAT and not know how to find this. I gave you an online function, but we need to make sure whatever calculator you use for your SAT, you can do this. Okay, so for these examples, I'm going to use the online function given to you in the instructions in Google Classroom. So here we go. You have a swimmer named Amy specializes in the 50-meter backstroke. Okay, and it says in competition, her mean time, there's the mean, for the event is 39.7. Okay, the standard deviation of her times is 2.3. Assume that Amy's times are approximately normally distributed. They have a normal distribution for all of her swim times. Okay, if you were going to estimate the probability that Amy's time is between 37 and 44, well, let's think about this a little bit. If my mean is at 39.7, okay, and my standard deviation is about 2.3. Let's go over one standard deviation up. See, 2.3, so I would be at 42 here, and over here I'd be, let's see, minus 2.3 for 37.4. Okay, so if you want to know if it's between 37, here's the 37, and 44, what would you say? You're just trying to estimate the probability. Okay, so when you look at that, the first time is a little less than the standard, than 2 standard deviations. 2. It's a little less than 2. Okay, over mean time of 39.7. The second is nearly 2 standard deviations above the 39.7. As a result, the probability of a time between the two excuse me, values covers nearly 4 standard deviations and would be rather large. Okay, so if I was just going to estimate, I'm going to say, okay, well, I'm going to estimate about 90%. She's got a 90% shot. Okay, and again, they're just asking for an estimate, but you're looking at 2 standard deviations on each side, so possibly 4 standard deviations. Okay, so this one we're going to use z-scores and a graphing calculator, and we're going to round our answers to the nearest 1,000, and we're going to find the probability that Amy's time in our next race is between 37 and 44. Okay, so do you see how I get my little data distribution over here? It's got to be mound shape, it's got to be symmetrical. Here's my mean right here. It's 30, what is my mean? 39.7. Okay, on each side, that's 37 and 44. My z-score right here is 1.870. There it is right there. That is 1.87 standard deviations from the mean. This one, the 37, is a negative 1.174. That means it's 1.174 deviations from the mean, that distance there. And if it's a normal distribution, seems like we should be able to calculate this area here in comparison to the whole thing and tell me what the probability is. Okay, so if you're using a TI-83 or a TI-84, you would enter in your z-scores like that. If you're not using the TI-83 and 84, if you use my online function, which I'm going to go over to, I'll show you how to enter it in. You're actually going to enter in the 37 and the 44. So let's go over to that, that guy. I got it up here somewhere. Let's see. there it is. If you pulled up that online function I gave you, if you put in the mean to be 39.7, standard deviation they gave us was 2.3. Okay, now in this one, they want the left bound to be 37, not negative 1.174. Okay, and in this one, they want the right bound to be 44. They're going to say calculate, and there it is. There's your answer right there, 0.84901. So let me go back. So I know the probability of it landing in there is about, well, it's exactly what did I get on the other one? 0.89? Let me make sure I got it right. Yeah, 0.849. Okay, so it's about 84% chance she's going to make it in this area right here, given that it's a normal distribution. Okay, what if you wanted to estimate the probability that Amy's time is more than 45 seconds? Wow, it would be all the way over here, and it would have to be anything that's over here. I think that would be very small. I would say maybe 3%. Because look, when we're doing probabilities, this is where it's got to land, somewhere under the curve, and under 45, there's not a lot going on down here. I'm going to estimate it about 3%. Let's go actually do it and find out what it is. Okay, so if you're going to do the z-scores, you got the 39.7, you got the 45, and it's going to be here out to infinity. Okay, so when you do this, you're going to put the z-score, you're going to find out your z-score is 2.304. Okay, and if you put it in your on your online, then you would get 0.011. You'd have to put positive infinity for the right bound. Okay, now when you go enter it in, if you're a TI-84, your z-score, you just have to put in something that is extremely high, like positive infinity. Okay, in order for it to work. Okay, strictly speaking, the aim here is to find the area under the normal curve between 2.304 and positive infinity. Okay, it's impossible to enter positive infinity in the calculator, so any large positive number can be used in its place. Let's go see what happens when I do that online calculator. Let's go see how that works. Let's go give it a try. Let's see, I have it over here. I have to come down here. Let's see. And I think I have to clear it. So let's clear it. The mean is still 39.7. Standard deviation is still 2.3, but my left bound is now going to be, let's see, 45. And the right bound, well, anything is as long as it's really, really big. But for positive infinity, it says use INF. Okay, let's calculate it. We got 0.010602. It was really small, very small possibility, 0.011. Okay, let me go back to our slide there. Okay, and that would make sense given the picture. Okay, what's the probability that Amy's time would be at least 45 seconds? To me, well, I'm not even going to do it. If I know this one is 0.011, it seems like I would just do 1 minus 0.011. Okay? But if you want to do it, you can go back into the normal distribution and put 45 as your right bound, and the other is the left. Let me show you that one. Oh, nope, I don't think I show you that one. But do you understand? It's the area under that curve, and if we already figured out what this probability was, you know what this probability is, because the total probability's got to equal 1. Okay, let's look at this. If you want to know, using z-scores in a graphing calculator, rounding your answers, here we go. What is the probability that in her next race is less than 36 seconds? So if I draw my little picture, it's right there, it's 36. I got my z-scores negative 1.609. I put it into my online function, and I get 0.054 or 5.4%. So out of the whole data, this gives me about 5.4, which that kind of makes sense because if you go back and you look over here, and when we do this one, remember how small that one was? That was like 1%. So this one is about 5%. Okay? Now, okay, let's do another example. The distribution of lifetimes of a particular brand of car tires has a mean of 51,200 miles, standard deviation of 8,200. Assuming that the distribution of lifetimes is approximately normal, you have to know that it's normal, and rounding your answers, find the probability. Will a randomly selected tire last between 55 and 65? So you would come in here and you would go, okay, my mean is 5,200 right there. My left bound right here, I'm going to do it up here so I don't make it, well, I guess I could put it down here, is 55. And then my right bound over here is 65,000. Okay, now that's what I would put on that online function. I would go and enter in the mean. I'd have to figure out the standard deviation is 8,200, and I can enter it in and I will get a probability of 0.275. If you were using a graphing calculator, though, you would have to determine your z-scores, okay, by subtracting it from, the mean and dividing by the standard deviation, okay, and you would have to enter your z-scores as your left and your right bound, okay. Now, if you're looking at a normal distribution, and this is about, that makes about sense, that's about 27% of the whole mound, okay. Okay, how about a randomly selected tire lasts less than 48,000 miles? If you were going to use my online function, you're going to use the same thing, but now your left bound is infinity, right bound is 48,000. Okay, if you were doing it in your calculator, you'd have to calculate your z-score, and that ended up coming out to, let's see, let me look at my notes because I can barely read that. Negative 0.39. Okay, and you would have to do your left bound is negative infinity, right bound is negative 0.39. Or you can use my online function for this particular exercise. Okay. If you wanted to do the randomly selected tire last at least 41,000 miles, so at least 41,000. Ooh, this is going to be pretty high. And sure enough, look, probability is 89%. Okay, if you were using my online function, you would need to know your mean, your standard deviation, where you pick. This would be your left bound. Your right bound would be infinity, positive infinity. If you're using the TI-84, you're going to have to figure out your z-score, which is a negative 1.244, and this would be positive infinity. Okay, now if you want to talk about, explain the meaning of the probability that you found. Well, this means that you have an 89% chance that those tires are going to last at least 41,000 miles or more. Okay, let's look at this one. Think again about the brand of tires described in exercise 3. What's the probability the lifetime of a randomly selected tires when within 10,000 miles of the mean lifetime for tires of this brand? Well, here's your mean. You add 10,000, subtract 10,000. Again, you'd have to find your z-score if you're using your calculator, and that's the one you're going to have to use on your SAT. And then you could come in and do the probability is 77.8% that it's going to be within 10,000 miles of the mean lifetime. Okay, Now, this is the last thing I want to go over with you, and we're going to do more of it in the next lesson, lesson 11. So some teachers always make you do it with the table, okay? They don't like you to use the graphing calculator. They don't like you to use the online function. And on your SAT, I was told they would definitely give you a table. So you would definitely have that ability. So I want to make sure that you can do this with a table. Okay, so if you pull out that table that I gave you just the table. It calculates the area under the curve, and it will help you as well. So let's go, and I'm going to explain to you how to read that table. So let's go to this one. Here we go. Okay, so the standard normal distribution, okay, is, you got a mean of 0, okay, and a standard deviation of 1. Okay, so on this particular one, it's 0 and it's 1.23. Okay, so you want to determine the area of the shaded curve. Okay, so you're going to have to go look at your table, and it gives the areas to the left of the selected z-score. Areas to the left of the selected z-score. Okay, and I'm going to stop here so I can pull up that table. I'm just going to stop and then restart. So I'm going to go pull the table up. You pull the table up, starts negative, go all the way down. You're using the bottom left, and I'm going to go to 1.2. There it is right there. Okay. And I need to find, because it was 1.23. There is my probability right there. 0.8907. Okay. That's how you use the table. So I know my probability is 0.8907 is my probability, which that makes sense. Isn't that about 90% of the total curve? Okay, let's try this one over here. Okay, this one, it's a negative 1.86, and they want to know what's the probability that's in this curve. So I'm going to go back to my table, and my table, I need to go up, because it's a negative 1.8. Here is negative 1.8, and it's 1.8, and then I'm going to go over to 6. Let me make sure where 6 is. Sorry. Starts at 0. So if I go negative 1.8, it's right here. There's 0, 1, 2, 3, 4, 5, 6, 7, 8. 0.0301 right there is my probability. Okay, now that tells me the probability. Okay, so remember, you have to go in the left-hand column. That's telling me the probability from the z-score of negative 1.86, okay, all the way over to what? To negative infinity. So if I want to know the probability that it's from negative 1.86 over to the right, then I have to do it like this. Then I have to come here and I have to say, okay, I figured out the probability to the left over here. To the left was 0.0, let me see, let me get this guy going. Let me get my pen working. So when you looked at that table, you found this probability over here. So if you want to know this over here, I would say 1 minus 0.0314. So the probability to the right is going to be 0.9686. So when you use the table, you're always finding the probability to the left. Okay, so if you wanted the probability to the right, you have to say 1 minus that probability. Okay, so let's look at this one. This one's also, now this one's a little bit interesting. So if you go from the left over to here, it's going to go all the way over there, right? How are we going to do this one? From here, I could figure out the area completely over here, and I could figure out the area over here and subtract it off. I think that would be a good idea to do it. So if I go to my table and I look up, what is this one, a 2? If I go look up 2, I get a probability of 0.9772. Everything to the left is 0.9772. That's the probability. But what's the probability to the left of 1? The probability to the left of 1 is going to equal 0.1587 when I go look in the table. So I'm going to take this probability and I'm going to subtract it from this one, and I'm going to get 0.8185 is the probability in between. Do you see that? The first one, if I look up the table for 2, I get the probability for the whole area to the left. Okay, if I look it up for 1, I get the probability of everything to the left of the 1. So I subtract this piece from the whole piece there. Let's try another one. Okay, here's another one. I want to talk to you a little bit about this. The price of printers in a store have a mean of 240 and a standard deviation of 50. The printer that you eventually chose cost $340. What's wrong with the following z-score, and how do you know? Well, I have a z-score of a -2, but if the mean is 240 and I'm above the mean, I have to be positive. I would have to be positive. And what they did was, it should have been 340 minus 240 for a plus 100. Okay, a swimmer named Amy specializes in the 50 meter. You found the probability that Amy's time is between 37 and 44 is 0.0849. So I would say the probability, she has an 84.9% probability of having a score between 37 and 44 seconds. Okay, here is your lesson summary. A normal distribution is a continuous distribution that has, remember, it's symmetrical and it's mound-shaped. Okay, the probabilities associated with normal distributions are determined by using z-scores and can be found using a graphing calculator or tables of standard norm curve areas. If you use the table, you have to know the z-score. If you use a graphing calculator, you have to use the z-score. However, if you use that online function I gave you, then it just wants what your left and your right bound is. But you will not have that online function when you go to your SAT. So you need to make sure you can use the table, which they will give you, and also you want to make sure you know how to use your calculator. Okay, good luck with your assignment. I think that's it.